Hello everyone, today our group would like to present our deep learning midterm project entitled Development of a Deep Neural Network Architecture for Safety Helmet Classification in Industrial Environments. My group consists of three members, Nguyễn Bá Ngọc, Nguyễn Minh Tuan, and Nguyễn Tu Phuong. My presentation consists of three main parts, five main parts. The first introduction, the second is dataset, the, the third is model, the next is training and evaluation, and the last part is conclusion. Let's move on to the introduction. Uh, Occupational safety is a critical issue in industrial and construction environments. Wearing safety helmet play a vital role in reducing head injuries caused by falling objects or accidental impacts. However, in practice, helmet compliance monitoring is still mostly performed manually, which is inefficient, inconsistent, and difficult to scale. And at the midterm stage, the project focused on a foundational task, which is helmet classification. This step is essential before extending the system to real-time helmet detection and safety violation monitoring. The next part is dataset. The dataset consists of two classes. The first is industrial safety helmet, and the second is motorbike helmet as a control group. More than 4,000 images were collected from public dataset and real-world photographs to ensure diversity in lighting condition and viewpoint. All images were resized to a 64 by 64 pixel and normalized to the range from 0 to 1. Each RGB image was flattened into feature vector of 12,288 elements before being fed into the deep neural network. That all for the introduction and dataset. Now my teammate Nguyễn Thu Phương will present the model.
So after preparing and pre-processing our data set, the next step is to design the model that will learn from this data. Let me now introduce the architecture of our deep neural network. Our proposed model is a deep neural network implemented entirely using NumPy. The architecture includes one input layer with 12,288 neurons, 5 hidden layers with size 256, 128, 64, 32, and 16, and finally an output layer with 2 neurons. ReLU activation is applied in hidden layer to avoid vanishing gradient, while softmax is used at the output layer to generate class probabilities. Optimization is performed with gradient descent and cross entropy loss. Next, once the model architecture was defined, we move on to training and evaluating its performance. Let me share with you the result we obtained. The model was trained for 4,000 epochs with a learning rate of 0.001. Results show very high training accuracy, near perfect performance on the test dataset, and stable prediction in real-world testing, often about 99% confident. Evaluation is based on two main plots, the loss curve which shows smooth conversion, and the accuracy curve, which increase consistently as the loss decrease. This confirmed that forward and backward propagation were correctly implemented and that the network parameters were optimized effectively. Hello.
Snake evaluation. My name is Ngoc. So about accuracy, overall correct class, classification rate, loss curve is convergence of training and confusion matrix class-wise prediction error. So we test true learning rate LR equal 0.01 and LR equal 0.001 and selected 0.001 because it provides much better stability for your file network. The evolution is shown through true matplot loss curve display a smooth and steady drop toward zero. This confirms that LR equals 0.001 is best choice to help the model learn without shaking. Oscillation accuracy curve increase consistently as the loss decrease. This provides the network e-learning real pattern from 12,288 features, not just memory noise. And the last is conclusion, and I will talk about the future work. In conclusion, this midterm project successfully established a foundation helmet classification system using a per-depth neural network. The results validate the correctness of the mathematical implementation and provide a solid baseline for future development. In the next phase, this classification model can be extended to real-time helmet detection, integration with camera system, intelligent occupational safety monitoring platform. So thanks for your attention. Here are all my presentation of my team.